Okay, so this is the November 2009 paper 2, which is calculator paper. This is the formula book, so you've got the area of a trapezium and the volume of a prism. You don't need to write on that page. And question number 1. So write down the number marked with an arrow. Here's 60, here's 70, this must be 75, so it's just going up in ones, and therefore that is 72. This one, here's 8, here's 9, which means this must be 8.5, and it must be going up 8.6, 8.7, 8.8, 8.99, so that one is 8.7. Find the number 320 on the number line and mark it with an arrow. Here's 300 and 400, so this must be 350, so it must be going 340, 330, 320, and it must be going up in tens, so you should have marked there. Question number 2. Here is a shaded shape. Find the area of the shaded shape. Now the word area means the inside of the shape and how many squares it's using up. So I would write on it to keep track of them. 1, 2, 3, 4, 5, 6, 7, 8. So the area is 8 centimetres squared. Find the perimeter. Now that's the outside of the shape, and I'm going to draw to show where I've started, so I know when I've got back to the same place. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So my perimeter is 14 centimetres. Here is a solid made of centimetre cubes. Find the volume of the solid prism. So this is how many centimetres cubed have been used to make it, but you have to take into account the ones you can't actually see as well. So there's 1, 2 here, 3, 4, 5, 6, 7, 8, and then here there must be 2 because it's too deep. 9, 10, 11, 12, 13, 14, 15, 16. So 16 centimetres cubed. Question number 3. The table gives some information about 5 girls. Their name, their age, the number of pets they have, and their favourite subject. Write down the name of the oldest girl. So we're going to look in the age. It's 13, the oldest, and it's Diana. Write down the name of the girl who is 11 years old and has 4 pets. So there's an 11-year-old here, Charlotte, and here, Adila, and they've got to have 4 pets as well. This person has 1 pet, this person has 4, so it must be Charlotte, who is 11 and has 4 pets. Write down the name of the girl who has 3 pets and whose favourite subject is art. So number of pets, there's 3 here for Diana and 3 here for Emma, and favourite subjects are PE for Diana and art for Emma. So 3 pets and art must be Emma. Write down the name of each of these 2 3D shapes. Well, this one here is not a cube because it's not all square, but it's a cuboid because it's made out of rectangles. And this one here is a pyramid, and the base is a triangle. So it's a triangular or a triangle based, that would be fine, pyramid. Here is a triangular prism. Write down the number of faces of this prism. Now a face is one of the shapes that's making up that 3D shape. So we've got a triangle face, a triangular face, and then 3 rectangular faces round the outside. So that's 1, 2, 3, 4, 5 faces in total. And the number of edges, I'm going to try and tick them off as I do it. So around this triangle there's 1, 2, 3 edges. Around this triangular face there's another 3, so that's 6, and then I've got these edges of these rectangles, so 7, 8, 9 edges. What fraction of this shape is shaded? 1, 2, 3 are shaded out of 1, 2, 3, 4, 5, 6, 7, 8. So it's 3 out of 8. Shade 0.7 of this shape. Now I need to work out what each of these squares is worth, the little squares. The whole thing must be worth 1 whole. So I'm going to try 0.1 and see if that works. 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1. Now because I counted up in 0.1s and I got to 1 whole, it must be that each one is worth 0.1. So that's 0.2 I've shaded, 0.3, 0.4 I've shaded, 0.6, 0.7. What percentage of this shape is shaded? Now you know that the whole thing is 1 whole or 100%. That's everything, isn't it? 100%. So I need to count up and work out on these how much percentage each one is worth. So I'm going to try 10, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Well, I got to 100, so 10 must be correct. So 10, 20, 30, 40% is shaded. Question number 6. Here is part of a train timetable. At what time should the train leave Doncaster? So I'm going to look at Doncaster and the time there is 8:36. So I can just write that one down. James arrives at Peterborough at 9:15. He wants to catch the 9:26 train. How many minutes should he have to wait? So we're going to think of 9:15, and the nearest place it's easy to jump to is 9:20, and that jump there is just 5 minutes. But the train isn't at 9:20, the train is at 9:26, so I'm going to have to jump again, and from 9:20 to 9:26 is 6 minutes. So I've made a 5-minute and a 6-minute jump, so that must be 11 minutes in total. The train leaves Stevenage at 9:58. It takes 27 minutes to travel to London. What time does the train arrive in London? Now I definitely need a number line for this one. So 9:58 is when it leaves, and I've got to account for 27 minutes. Now the easiest place for me to jump to from there is 10 o'clock, because from 9:58 to 10 o'clock is 2 minutes, but I need to make 27 minutes, so I need to do another jump of 25 minutes, so that in total I've jumped 2 and 25, I've jumped 27 minutes. So from 10 and then a jump of 25 minutes makes me up to 10:25. So it must arrive at 10:25. Question number 7. William asked some of the students which flavour of crisps they liked best, and he drew a bar chart to show the results. Write down 2 things wrong with William's bar chart. Well, okay, so a good bar chart should have a title. So number 1, no title. A good bar chart should also have scales labelled, so it's got frequency labelled and flavour labelled, so that's okay. A good bar chart should also have a sensible scale, so it's going up 2, 3, 4, 5, 6, 7, 8, 9, 10. It's going up sensibly by 1 at a time, apart from here, where it jumps from 0 to 2. So the scale misses out 1, and then the scale on the other one we can look at, and there's actually a label here missing, so a missing label for the flavour. So I've given 3 reasons there, any of those 2 would be fine. Question number 8. Here are the first 4 terms of a number sequence. So let's have a look at this sequence. 5 to 9 is add 4, and again add 4. So the rule must be add 4. I don't even know what the question is yet, but I'm already thinking about what it might be. Write down the next term. Well, if it's add 4, I need to do 17 add 4, and I will get to 21. Explain how you found your answer. Add 4. The 25th term of the number sequence is 101. Work out the 26th. Well, if I've got the 25th and I know I add 4, then the next one, the 26th, must just be 105 because I've added 4. Write down the value of 10 squared. Now, a very common incorrect answer here would be 20 because it would have been to do 10 add 10. But we know squared means times by itself, and 10 times 10 is 100. Write down the value of the square root of 49. So something times itself makes 49. So we need to work out what number times itself makes 49, and that number is 7. Write down the value of 2 cubed. Now a very common wrong answer here would be to do 2 add 2 add 2 and get 6. But we know that 2 cubed means 2 times 2 times 2. 2 times 2 is 4, times 2 again is 8. Question 10. Here is a list of 7 numbers. From the list, write down the odd number larger than 20. So bigger than 20, we've got these 3 at the end to choose from. 28 isn't odd, 33 is odd, and 36 is not odd, so it must be 33. The prime number. So a prime number is only in its own times table, and it only has the factors 1 and itself. So 16 has 2 as a factor, can't be that. 18 is in the 2 times table, can't be that. 19, can I think of any times tables that 19 is in? Apart from the 1 times table and the 19 times table, no I can't, so it must be 19 because it only has 2 factors of 19 and 1. 2 numbers with a difference of 10. Now difference means subtract. So when I subtract them, I get 10, or they're 10 apart. So I'm going to look at the list. 16, I'd need 26. 18, I'd need 28. Oh, look, I've got 28. So it must be those ones, 18 and 28. A multiple of 9. So something that's in the 9 times table. So I'm going to start thinking of my 9 times table. 9, 18, up, 18's there, must be that. Question 11. This quadrilateral has 2 pairs of equal sides. So these 2 are the same length because the dashes are showing me that, and these 2 are the same length because the dashes are showing me that. Write down the special name. Now, it's not got any parallel sides, so it can't be a parallelogram, and it can't be a trapezium. It doesn't have any right angles, so it's not a square or a rectangle. It's either a rhombus or a kite. Now a rhombus is like a diamond and all the sides are the same, but they're not all the same in this one. There's 2 long ones and 2 short ones, so it must be a kite. On the diagram, mark with the letter R the right angle. Well maybe there is a right angle. There is a right angle, here it is. We'll mark it with an R. But since there's only one, it must still be a kite. Write down the special name for the angle marked X. So it's either an acute, an obtuse, or a reflex, and since that's less than 90, it must be an acute angle. Okay, question 12. Rosie made a list of her test marks. Write down the mode. Well, the mode is the most common. So she's got 2 2s, 2 3s, and 3 7s. So 7 is the most common number. Work out the range. The range is the difference between the biggest, which is 10, and the smallest, which is 2. So the difference is 8. Work out her mean mark. So the mean, I have to add them all up. So I've actually got a calculator, so I don't really need to write this down, but I'm trying to show all of my working. And the most important thing I do here is that when I add them all up, I remember to press equals at the end. 45. And now I need to divide by how many there are. There are 1, 2, 3, 4, 5, 6, 7, 8, 9. If I didn't press equals before I did divide, I wouldn't be dividing everything. I'd only be dividing the last one. So 5 is my answer. Simplify. 3p add 4p. Well, there's 7 p's in total. Simplify. E times f times 5. Now, we know that e times f, we can be lazy and just write ef. And to say times 5, we can just write 5ef. So 5ef or ef5 would both be correct. Simplify. Y squared, y squared, y squared. Now that's 1y squared and 1y squared and 1y squared. So that's 3 lots of y squared. Now this is quite a tricky question, because if it was y squared times y squared times y squared, we'd get a different answer. Have a think if you know what that answer would be. You're right, it's y to the power of 6. Okay, so question 14. Here we've got a diagram. This is a straight line, and the angle, the side AB is the same length as the side AC, which these two dashes are showing us. So it's an isosceles triangle. Work out the size of the angle marked X. Okay, well, we know in a triangle that all 3 angles add up to 180 degrees. So 65 add this one, which must also be 65 because it's an isosceles triangle, add y must equal 180. Do I need to do that? I'm trying to work out X and I've started working out Y. So here I've actually started working out the wrong question. So I'm going to rewrite that there. Okay. So to work out X here, I know that these 2 angles here are on a straight line. So 65 add X must equal 180. So I need to work out what I add to 65 to make 180, or I could do 180 take away 65, which is calculator paper, 115, so it must be 115 degrees, because angles on a straight line, and straight line is the important phrase, and 180 is the important number that you must say to get your mark. So now work out the size of angle Y. So this is the one that I'd started doing. I know that this is an isosceles triangle, so the 2 angles at the base must be the same, they're both 65. And I know angles in a triangle add up to 180, so that must total 180. So 65 add 65, so I've got 130 add something makes 180. So I'm going to do 180 take away 130 on my calculator to get 50. So Y must be 50 degrees because it is an isosceles triangle. So 2 angles are the same and all 3 angles add to 180. So here the important words are isosceles triangle for a mark, 180 degrees for a mark, and 2 angles being the same for your 3rd mark. Question number 15. This graph can be used for changing between miles and kilometres. So kilometres is up here on my y-axis and miles is along here on my x-axis. Use the graph to change 12 miles to kilometres. So I'm going to go to miles and I'm going to look for 12 and I'm going to go up to my graph. You must do this very accurately, preferably with a ruler. And I'm going to go across, and in kilometres I've come out there, which is 16, 17, 18, 19 kilometres. 19 is the only correct answer if you've done it accurately. Use the graph to change 10 kilometres to miles. So I'm changing kilometres now, and I'm changing 10. So I'm going to go across at the number 10 and go down, and I come out at the number 6 in miles, so it must be 6. Matthew travelled 100 miles. Change 100 miles to kilometres. So I'm going to go to miles, and when I look across, I see that there isn't a number 100. So I need to find a number that I can easily get to 100 from. And I'm going to choose 10, because that's the same as 100, but missing a 0. So I can just times by 10, couldn't I, to make that 100. So if I look up 10, that gets me 16. So 10 miles equals 16 kilometres. But I was asked about 100 miles, which is just a naught added, or times by 10. So I must add a naught, or times by 10. So it must be 160 kilometres.